Okay, so some of the kids are here, so we can get started. So we have Shiv and we have Tanvi, and I see some of the kids walking in. All right. So in the previous class, somebody is missing, and that is Sahit.
I went on vacation.
He's on vacation. Yep. So, all right. So in the previous class, we started talking about arithmetic progression and series, and we looked at some of the ways how the formula for nth term or sum of n terms is derived. Do you guys remember the basic concepts? Or Shiv, you were not there in that class, right? So it will be sounding a little new to you. So let me quickly go through what we covered in the previous class, and I'm not trying to go through it to repeat it for you guys, but it'll be a good point for us to compare. Yeah?
Yes, sir.
Okay. Tanvi, are you okay with that?
Yes, sir.
Arush and Davik, no concerns with the teacher? Okay, okay, good. See, I have a habit of getting certificate from you guys that every class I will say, okay, no concerns with the teacher, no complaint with the teacher. But yeah, again, on a serious note, let's look at what is called arithmetic progression, or let's not call it progression, I'll call it sequence. And on purpose I have colored part of the board where I will not be writing, because this is where you see the reflection. So I'll not use this circle. Okay. So one is arithmetic sequence, and extension of that I will say arithmetic series. Similarly, the new thing that we are going to learn today is called geometric series, sequence, series, and we'll compare these two. So in the last class we talked about this one. Now when you look at arithmetic series, let's say what is sequence. Let's say 2, 6, 10, 14, 18, so on and so forth. This is called arithmetic sequence. The numbers are in a sequence such that every two consecutive number has the same difference, which is, and the difference is, since the difference between two consecutive numbers is common, it's called common difference. And so this is, and in any sequence that you talk about, the first term, first element of that sequence is very important, because that plays a very important role in deciding what is going to be the fate of the arithmetic sequence. Okay. So 2, 4, 6, 10, 14, I mean this is just an example. So here the first term, the sequence starting from 2, this is called first term. Here the A is, which is the A, it denotes the first term, is 2. And the common difference, I'll call it D, is 2 to 6 is 4, 6 to 10 is 4, 10 to 14 is 4, 14 to 18 is 4. So this is a common difference. If with any mischievous intent I change it to 19, you will say that please delete all the numbers that you have on the board. They are not part of the arithmetic sequence. Yeah. So I have to abide by the protocol or the difference or the understanding or the rule to make sure all the numbers are aligning with the basic rule of arithmetic sequence. Yeah. Now what is arithmetic series? Arithmetic series is nothing but a sum of all these numbers that you see here. So you might have a need to add first 50 numbers, first 10 numbers, first 20 numbers, first 2 numbers, whatever it be. So let's say this is my first term, this is my common difference. What will be my nth term? Nth term will be A plus, okay, I'll not call it an, let me call it term n. Nth term of this sequence will be A plus n minus 1 times d. This is what we derived in the last class, correct? And I'm not going to derive it one more time, because since you were not in the class, I would request you to just go through the video of the last class if you have not done that already. So you'll be clear, and if there is any doubt, catch hold of me. Okay? So this again, just to relate, this is the first term. If you are talking about the second term, you'll replace n with a 2, and you'll see that second term becomes 2 minus 1 is 1 times d. What is my d? 4. So 1 times d, which is 1 times 4, which is 4, and my first term is 2. So that is how the second term becomes 6. And you can keep on replacing the value of n, and you will find that. Okay. Is everybody okay with whatever I have said so far? Shiv, are you able to catch better so far?
Yes, sir.
Okay, alright. So we just saw what is arithmetic sequence, and we saw that nth term of any arithmetic sequence would be a plus n minus 1 times b. And we have proved that in the previous class. Just watch the video of that class one more time. If you have any doubt, I am here to do it one more time. Okay. Now, as I said, the numbers that we saw, they were in a sequence. They are called arithmetic sequence. What do we mean by series? I mean, this is a term that you will come across very often. Okay. So okay, find out the arithmetic series of first 10 numbers. So basically, they are talking about arithmetic sequence and sum of first 10 numbers in that sequence. Okay. And here we derive the formula of that as sum of n terms of an arithmetic sequence, or sum of 10 terms of sum of arithmetic series of n terms is, we found the formula as n by 2 into 2a plus n minus 1 times d. And again, this might look like, I'm forcing you guys to memorize this, but trust me, there is nothing to memorize. We just learned, or we found out how to derive this formula. If I want to memorize this or remember this in a simpler way, it is a plus nth term. Because nth term is a plus n minus 1 d. So this is your nth term plus 1 extra a. So that is how it relates to that. Okay. So let's say tomorrow if you have a problem to solve, right? It says find out sum of first 50 terms. Okay. It starts with 10 and the common difference is, let's say, 5. So first term is 10, 15, 20, 25, so on and so forth. It says, okay, find out the sum of first 50 terms of this sequence, arithmetic sequence, or find out the arithmetic series of first 50 terms. So you will say, okay, my formula is this. First 50 terms, so my number of terms is n is 50. So this becomes 50 divided by 2, n by 2, times a plus nth term. A is my 10 and nth term. I can put in this formula, or I can find out the nth term, which will be here. So 10 plus 50 minus 1, 49 times b, which is 5. So let's say my 50th term is 10 plus 50 minus 1 is 49 times 5. 49 times 5 is 245. So 10 plus 245. Yeah. So you guys are much better off. You guys have calculator in front of you. I was not having the luxury of having calculator till I joined my engineering college. I mean, those were the times. I mean, we were not having that option. But that's okay. I mean, there's nothing to complain here. So this is my 50th term is 10 plus 245, which is 255. So 10 plus 255, and I can do whatever calculation I want to do. This part is okay, right? So far, I'm just saying that how the formula was derived and how we can apply that for finding out sum of n terms. Yeah. And different people, different questions, different teachers, different exams will give it different terms. Say, okay, find out the partial sum of the arithmetic series of first 10 numbers. Partial sum, full sum, whatever sum you call it, ultimately it boils down to how many numbers you're trying to add following that series or sequence. Is everybody okay?
Yes, sir.
Shiv, okay, beta?
Yes, sir.
Okay. So now, and if you guys don't remember how did we do it, right? I'll just give you guys a quick clue. Sum of n terms, we got this as n by 2 times 2 plus 2a plus n minus 1d. And what did we do was, we said, okay, sum of n terms is, let's say a plus d, a plus 2d, and went on till a plus n minus 1d. Nth term we went over to this, okay, and that then what we did was we said, okay, I will just reverse the order. We reversed this thing, we brought the nth term first and then went until first term. And when you add these two, you will see that this becomes 2a plus n minus 1d. This thing. And when you are adding these two, it becomes 2a plus n minus 1d times the number of terms you have in the sequence. So that is how it became 2 times s will be equal to n times this whole value. So s will be equal to n by 2. So I am just giving you as a clue, just to help you recall what we did in the last class. Okay. So just a weird question, okay? So Tanvi, this is your second class, I guess, right? Just to get some feedback on this one. So when I'm uploading the video, are you guys able to get some benefit out of the video, or it is only for me to get some views? It's helpful, right? Because I don't get views. I don't have subscribers. I'm not a YouTuber. Only thing I have is you all, my students, my kids. That's it. Okay. So as long as it is solving the purpose for you guys, I'm doing okay. Tanvi, is that a good observation or a bad observation? Is it solving a purpose for you guys?
Yes.
Okay. All right. So I will not claim to be a YouTuber. Okay. I'm not a YouTuber. I'm a teacher. So the video is only, YouTube is only giving me the opportunity to kind of leverage the platform free of cost. I'm not paying anything to YouTube. That's why I'm using it for you guys' benefit. Alright, now let's come to geometric sequence or series. So same thing like arithmetic sequence, when we talked about the numbers one after another, that group of numbers is called sequence, and they have certain rules to follow, and some of them is called arithmetic series. Same interpretation we can apply for geometric sequence and series also. When you have a group of numbers following a certain rule which qualifies them to be called a geometric sequence, that is geometric sequence. When we talk about series, we are talking about some of them. Okay. Now let's look at. So I'm rubbing it off. Okay. I'm not wanting to keep this so that I have bigger part of the board at my disposal. So what I'll do is arithmetic sequence, and I'll put the formula here just for your reference. Tn equals a plus n minus 1 times d, and sum of n terms is equals n by 2 times 2a plus n minus 1 times d. Okay. Yeah. Okay. Now let's use this board for talking about geometric sequence and series. Now, arithmetic sequence and series, you guys are clear. You know that when there is a very standard, predictable, common difference between any two consecutive terms, that is arithmetic sequence. What is geometric sequence? What is a geometric sequence?
Represent by multiplying.
Multiplying. Okay. How about Tanvi and Shiv? Any idea, thoughts?
Common divisor.
Common divisor. Okay.
It's like a common ratio.
Common ratio. Okay. Let me. Okay, Shiv. Any thoughts, beta?
That's fine. You can continue.
Okay. So here, let me make this more like a layman's definition of arithmetic sequence and geometric sequence. Okay. Now let's look at it. When you are talking about arithmetic sequence, I am talking about plus and minus. When you are talking about geometric sequence, I am talking about multiplication and division. How about that? Plus or minus, arithmetic sequence. Multiplication or division, geometric sequence. Now let's look at it. So, based on whatever you guys told me, okay, I am not teaching anything new. You guys already know it. So if let's say I have 2 10, 50, 250, this versus 2, 6, 18, 54, 165. If you have to choose between these two sequences, which one you think is a geometric sequence and which one is not, and you have to tell me why. And again, you might be knowing it, you might not be knowing it. The question is meant for making sure that our understanding is rock solid. So first sequence is 2, 10, 50, 250 and continues. Second sequence is 2, 6, 18, 54, 165. Yeah.
First one is geometric.
First one geometric sequence.
I agree with him. The second one is.
Second one is not. Okay. Tanveen, save any second thought?
Yeah, I think the first one is geometric because it's like times 5 times 5.
You have the same understanding, Tanvi, as well, Beta?
Yes.
Okay. So going by the basic definition of a geometric sequence is when the ratio between two consecutive numbers of the sequence remains fixed. If you go back to the previous definition of arithmetic sequence, we said the difference between two consecutive numbers. Here we are saying the ratio. Now ratio you can get by dividing or by multiplying, doesn't matter. I mean ratio as in this divided by this. 10 divided by 2 versus 50 divided by 10 versus 250 divided by 50. All are same, 5. Like what Shiv also mentioned, right? So when the ratio remains the same. Now it need not be in increasing order always. It might be in decreasing order. It could be like 10 to 0.4 0.8. Okay, meaning when you divide this by this, this by this, 2 by 10 is 0.2, 0.4 by 2 is 0.2, 0.08 by 0.4, 0.2. So basically, sorry, all this ratio is coming to what? This is 0.2, 2 by 10 0.2, this is also 0.2, 0.2. I mean, I'm hoping that I picked up the right numbers. But net what I'm trying to say is whether the next number is multiplied by a natural number or by a fraction doesn't matter. The only rule of thumb that we have to follow is the ratio between two consecutive numbers is same, and that we can achieve by every number being multiplied or being divided by the same number. Both apply. That's why I was saying arithmetic sequence is plus or minus, meaning in case of this, if your common difference is not plus, if it is minus, let's say minus 2, so every next number will be 2 less than the previous one. Yeah, but your underlying principle remains the same. There is a difference, and nobody is giving us a mandate that the difference has to be positive always. It can be negative difference also. Yeah. Is everybody with me? Shiv, Tanvi, Arush, Davik, everybody with me? Okay. And I keep on asking this question, is everybody with me? Now the question is, do you guys have a choice? You have to be with me in the class. That's the only way I can be effective. Alright. So coming back to this one. So we saw that, okay, what is the basic definition? If I have any two consecutive numbers, the ratio of any two consecutive numbers remains the same. That is a geometric sequence. Now, so let's pick up an easy one so that no, I don't get lost in the calculation itself. Let's say I have 3, 6, 12, 24, 48, 96, 192, and it goes on. Whenever you have a sequence to deal with, first thing you should start with is this an arithmetic sequence or not? You see the difference is 3, and then 6, and then 12. So basically, it's certainly not a common difference that you see between any two consecutive numbers. So this is certainly not an arithmetic sequence. Now we are trying to see, okay, 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24, 24 times 2 48, and goes on. So this is a geometric sequence. Everybody with me? Okay. Now, let me not go this far. Let me stop here itself. That I have, let's say, 3 numbers. Okay, I'm saying the same pattern will follow. So I have 3, 6, 12. And I'm trying to find out what will be the 20th number, 20th term in this sequence, 20th value in this sequence. How do you do it? Give me a thought process. Can I sneak inside your brain? Or let's say I'm kind of in a very mischievous mood. I'm trying to find out the 500th term of the sequence. If you do it step by step, it might take you at least an evening for sure after the class. You certainly don't want to do that because you see a pattern. Whenever you see a pattern, you have to always look at, can I generalize this pattern? Can I define a standard form where I'll just plug and play? Yeah.
So define the 500th term.
Mm-hmm.
So it would be the starting number, so A times the number that you want, so 500
Ratio.
minus 1, and then that multiplied by the change. So this one is 2. So 2.
What is that? Say that again.
So this one.
Let's
would be,
say, let's start with, okay, you're saying 500 term.
Mhm.
Will be what?
3
3.
times
Uh-huh.
500 minus 1
Okay.
times again
2.
2. Mhm.
Okay. And I'll be ruthless in saying this is wrong. Okay? I'll be ruthless in saying this is wrong. Why? Because we are trying to generalize this, okay? So again, but here, look at this, okay? Let's not worry about this, okay? Let me give you guys a generic formula for this. Remember when we talked about arithmetic sequence, right? We looked at how do we generalize this. So now let's see. Here my first term is, let's say, 3. Yeah? What is the ratio between the any two consecutive numbers? Ratio, I'll call it common ratio because it's a common ratio between two consecutive numbers. Right? It is 6 divided by 3 or 12 divided by 6 or whatever comes next divided by 12. Okay. So I'll call this R for now. Okay. I'm not worrying about the number for now. Because my plan is to generalize this. Now let's try fitting this in here. Okay. This is my A. This is my A times R. This is my A times R times R. A times R times R times R, and then the journey continues. Is it making sense to everybody? So this is going on. Now I'm still trying to observe this. Now you look at this. My first term has only A. My second term has A times R. Let me simplify this. A times R, I will put this as R square. R times R times R, I will put this as R cube. And it just goes on. Okay. Now I'm reading the values that I'm seeing on the board. My first term is A. My second term is A times R. My third term is A times R square. My fourth term is A times R cube. My fifth term is A times R4. Sixth term is A times R5. What is the observation we are making? My nth term is, this is my third term, see the power, 3 minus 1. This is my second term, see the power, 2 minus 1. This is the fourth term. See the power, 4 minus 1. See the first term. See the power. Can I say this as 8 times r to the power 0? First term, 1 minus 1, 0. Anything to the power 0 it gives me a 1. Yeah? So I'm just trying to generalize this so that, and I'm not excluding the first term, okay? This guy should not feel like a stepchild, okay, in the whole sequence. Yeah? So, this is the first term, this is my second term. Now look at it carefully, okay? My first term is a times r to the power 0. My second term is a times r to the power 1. Third term is a to the power r times 2. I'm not r times 2, r to the power 2. Fourth term is a to the power a times r to the power 3. Fifth term will be a times r to the power 4. Sixth term will be 8 times r to the power 5. Nth term will be 8 times r to the power n minus 1. This became my generic method or generic formula for deriving the nth term. Now Arush, tell me if this is making sense. Yeah? Okay. And guys, if I tell anybody that your answer is wrong, I'm just giving you guys an opportunity to think, rethink, okay? Because math is all about thinking. If you ever noticed, and there's been many a times when my kids tell me, sir, you did a wrong calculation, I'm perfectly fine with that. It's about the math, okay? So here, from this, I want to come up with a generic convention, generic method, generic formula, which will say my nth term of a geometric series would be a times r to the power n minus 1. Now if you relate this with, okay, but before I go that far, here my nth term is a times r to the power n minus 1, and you might want to revalidate it one more time. My first term would be a first term times r n minus 1. So 1 is first term is 1, so n is 1, 1 minus 1 is 0, r to the power 0 is 1. First term is a. Second term is a r. How do I do that? Second term, n is 2, 2 minus 1 is 1, meaning a times r to the power 1. So this formula looks acceptable. Before I move on, Shiv and Tanvi, do you guys see merit in what I'm saying, or you want to rule it out?
Wait, so that means if we are doing what you said, then that means A would be 3, R would be 2, right? So
Right.
then whatever we need to do, so to find the En, right, that would be, so then we just need to get the N which is there, and we have A and R already, so you just need to do the operation, which is very easy.
Yeah.
We have a calculator.
Yeah. So I'm just first we have not done any calculation yet. We are just trying to wrap our head around this whole concept to say, if I know there's something called geometric series, if I not series, I keep juggling between series and sequence. If I have a geometric sequence and I know what is my first term, if I know what is my ratio, I can use this information to find the nth term, be it the 20th term, be it the 2000th term, be it the 10,000th term, just by using this generic formula. Yeah? Tanvi, do you agree with her? Okay. So now, going back to my original question, I said, okay, find out the 20th term in this series. Okay, T20, 20th term. So my value of n is 20. My first term is A is 3. So 3 times my R is 2. 2 to the power n minus 1. My n is 20. 20 minus 1 is 19. Okay. Now, I am not going to spend my entire evening doing 2 to the power 19. That is where you can use calculator, because that is not a value-added exercise. Okay, I will not take credit for calculating 2 to the power 19. That you guys can find it out. Okay. So that is where you guys having the calculator is a good thing. In my days, we used to use log for doing that. Okay, that is a little more cumbersome, but more mathematical approach. But why to reinvent the wheel? This is fine. Yeah. Is everyone with me so far? All right. Now, so now let's see. We will have to keep on going back to what we have done, what we have understood, and what is the correlation, right? So here, in case of geometric series, my nth term we saw that it is a times r to the power n minus 1. Now you can relate this one with this formula, okay? This is arithmetic series, arithmetic sequence formula, and this is geometric sequence formula. Here your nth term is a plus the common difference times n minus 1. Here it is a times the common ratio to the power n minus 1. That is how you can, I mean, just if you keep both the picture in your mind, it will be easy. And you don't have really to memorize, because here you are adding the common difference for every subsequent term. Here you are multiplying the common ratio with every subsequent term. That's why this is in the terms of power, this is as an addition. Yeah? Now, what is the equivalent of this guy? If I say sum of n terms, let me give it a different name. I'll say sum of geometric sequence. Okay, I'm just making it up. Okay, there's no standard convention for this one. I'm just making it up for now. Sum of this one will be equal to a times 1 minus r to the power n divided by 1 minus r, and then you guys will start jumping on my head saying, why are you forcing us to remember this formula? So let's forget it for a little bit, okay? We'll not even talk about it. We will try deriving it, okay? Because I mean, I'm not sure if I've written the formula correctly or not, okay? I am very poor. I might fail in maths if somebody says that your mathematical abilities will be a function of how much you memorize. I'll get an absolute 0. So let's try finding it out. Sum of n terms. Now we know it's a plus ar plus ar squared plus ar cubed plus ar to the power n minus 1. This is my geometric series where I'm trying to add first n terms. Yeah, this is what we saw, right? A generic formula: a r to the power minus 1. So first term, second term, third term, fourth term, fifth term, fifth term, and nth term. When I add them together, that's what we're trying to derive. Yeah? Am I getting you guys tired? No? Tanvi, Shiv? No? Okay. Tanvi will be all fresh. It's morning for her. She's in Philippines. So this is truly a global class. I have kids from Philippines, I have kids in US with me, and I have kids like Shiv being remote. So we have all 3 flavors and covering 2 countries. Alright, so here, and again, Tanvi is just traveling to Philippines. Alright, so here we have, this is what we are trying to derive. And if I just put this in layman's term, and tomorrow I'll say, okay, find out the sum of first 50 terms, you will keep on scrambling, putting a lot of unproductive effort to derive that. Do you guys want ice cream? No? Alright. So, I'll have to let this guy go, okay? So he's just getting me tempted to buy ice cream, okay? I cannot offer that to you guys, but okay, we'll find a way. Alright, so this is sum of n terms. There's nothing complicated about it. I've just put it across, okay? This is what we're trying to derive. Yeah? Now, I got a fancy idea. What I'm seeing is, I'm multiplying r every time. What if I multiply this sum also with a r? What will happen? My a will become ar. So what I will do is I will start writing it leaving one first step, first place. AR square, AR cube. At this place it will be AR to the power n minus 1. And then there is one extra term because I have multiplied by R. My last term is getting one extra R. So this becomes A R to the power n. Yeah? So I'm just repeating. See, this is the sum that we are trying to find out. I have written that in the lamest possible way. I just put all the terms in that sequence for first n. For first n terms. Yeah? And then I'm saying same thing. I just got a fancy idea that okay, if I multiply everything by R and then start writing from the second place, now I'll tell you what is that was cooking up in my mind. Now if I subtract the second equation from the first one, see what is happening now. These two are gone, these two will be gone, these two will be gone, this will be gone. What will be left with on the right hand side will be just this A because there is nothing equivalent to this guy, minus this last term where we got R to the power n. Yeah? And here what do I have? Sum of n terms minus R times sum of n terms. Yeah? So, but before I move on, is this looking somewhat relatable, digestible, tolerable? Yeah? Tanvi and Shiva, I'm waiting for you guys because I cannot see your faces. I don't know whether you are saying yes or you are saying no.
Yes, sir.
Okay. Shiv, okay. So Shiv has a shortcut. He used the thumbs up instead of nodding his head. Okay. So here, what happened was all this, see, here n is not defined. It's a variable. It could be first 50 terms, it could be first 500 terms, it could be first 2000 terms. Right? It's just a sequence that's just going on. Correct? So, in our attempt to minimize the number of terms that we are trying to deal with, we came up with this approach. And I'm not claiming that this is something that I have derived. This is something that I have learned as a student. Okay. Now, you look at this whole calculation. This looks much more cleaner. Here, sum of n terms is common anyways. If I take that out, it becomes 1 minus R equals. Here also I have A common, I'll take that out, it becomes 1 minus R to the power n. So if I have to find out sum of n terms in a geometric series, that will be nothing but A times 1 minus R to the power n divided by 1 minus R. So when I was rushing for showing you guys the formula, I was making a guess probably based on all the practice that I've done in the past, and I was able to recall it. You guys will also be able to recall the formula for sure because it's all about practice, right? More practice you do, you'll become more familiar to this. This will become more familiar to you. But I'm still not emphasizing on you guys breaking your head to find this out. I mean to remember this. I would rather say, keep this thing in mind that okay, I have sum, multiply that with R, subtract it, I am getting only two terms here. First term and the n plus 1 term here. This is like n plus 1 term because my nth term is always n minus 1, power n minus 1. Here I have this, so basically I am going one step forward. And then when I subtract this equation from this one, this is what I get. Now, is this clear to everybody? And again, as I said, I cannot see your head shaking this way or this way. Okay. So Tanvi and Shiv, is this looking okay? Acceptable? Okay.
Yes, sir.
Okay. All right. So we found a formula for summing up first n terms of a geometric series, which is A times 1 minus R to the power n divided by 1 minus R. Now the beauty of this formula is that you can use it for, I mean, you will see problem saying find out the partial sum of first 4 terms. What is partial sum? It is sum. They use different terms. Don't get misguided by those words: partial, full, half, fractional, whatever. It's just asking us to find out the sum of first n terms. Okay. Now, let's say somebody says you have a sequence. Let's say 7, 14, 28, 56, 112, 224, and just goes on. Find out sum of first 5 terms, or first 6 terms, or first 10 terms. Okay? You will not worry about first 10 terms, meaning it's asking us to use n as 10. And we know what is my first term. We know what is our common ratio. Okay, if it's a geometric series. Okay, let's say if I have to find out sum of first 10 terms, what will that be? What is my A here? A is 7. So whenever you are dealing with a geometric series or arithmetic series, right, always first try deriving what is, just make sure that your understanding of what kind of series it is right. Then find out what is the formula that you remember, okay, and then look at the value of all the variables that you are going to use for deriving the final thing. So here my first term is 7. What is my common ratio? The ratio between 2 terms, this by this is 14 by 7, that is 2. And saying first 10 terms, so my n is nothing but 10. Let me substitute this whole thing in this equation and see what happens. 7 times 1 minus r 2 to the power 10 divided by 1 minus r. 1 minus r. R is 2 again. So this becomes 7 times 1 minus 2 to the power 10 divided by minus 1. And then we'll find it out. So 2 to the power 10 you can find out. 2 2 is 4, 2 is 8, 2 is 16, 2 is 32, 64, 128, 256, 512, 1024. 1 megabyte. Okay. So this is 7 into 1 minus 1024 divided by minus 1. So this becomes 7 times minus 1024 to 3. This is 1 and this is minus, divided by minus 1. So this minus gets cancelled out. So 7 times this value is what your answer would be. So it's not about the answer, okay? I mean, I keep on making a very blunt statement saying I don't care about the answer. Trust me, I don't. I don't really care about the answer. Because what I would focus on, or what I would want you guys to focus on, would be to be more clear about the concept, the approach, the step-by-step process, and how do you build your story while solving the problem. See, when I'm solving the problem, I'm actually saying, okay, fine, this is my geometric series. I'll probably write a story also, say, okay, this is a geometric series, this is my, when I'm solving it, okay, where my first term is 7, so A equal to 7. Common ratio is 2, that is R equals 2. We have to find out some of first 10 terms, so N is equal to 10. If I'm writing that story, I mean, if I have the time, and then I'll go through it one by one, step by step. So that way, chances of, see, from here to here, I could have jumped very quickly, say, okay, 2 power 10 is 1024, 1 minus this. I'm not doing that. I have a very bad habit of doing it step by step. So that if I go wrong here and my answer doesn't match with one of the multiple choice questions that I have, I would know from where to start and where I can decode the problem. Okay. See that you find that approach helpful. I would prescribe that. I have no ways to insist on that, but I would prescribe it. Okay. Is this part clear so far? See, your teacher is not moving unless I hear a yes or no. Yeah?
Yes, sir.
So, can somebody summarize what we have discussed so far?
So basically we derived. Do you want me to start from like all the way at the start, or?
Just see, see, this is again. You don't have to answer this because I'm asking it. Okay, I have zero value in life. Why I'm asking you to tell this is how you will kind of compile in your mind. Okay, what did I learn today? Okay, I learned this. I learned this. So that is more of an exercise that you're doing for yourselves. Now you try answering this.
Okay, so first we found the term again for geometric sequence, which is a times r to the power of n minus 1, and we found that by saying that each time each time you go one up in the sequence, it's like how do I? It's like it's the number. It's like I can't really explain it, but it's like I have it in my head.
Yeah, no, I know that. See, I'll tell you one thing. Okay, again, this is out of syllabus. Okay, why I keep on insisting on certain things. Okay, my job is very easy if I just solve the problem and say, okay, I'm done. Why I'm telling you these things to you guys is because whatever you know, okay, there are two parts to it. One is knowing it, and second thing is letting everybody know that yes, you know. That is where the storytelling thing comes very important for us. Okay, because see, we might know 100 things, okay, but when you guys start feeling that or getting into that fierce competition, right, where everybody is at the same level, but for you to get the edge, you have to let the whole world know that you know. So this storytelling, the art of storytelling, right, I will keep on telling you guys, keep on guiding you guys to get into that habit, because that will be very important. Trust me, when you go to college and you become a good storyteller, it's not about telling story as in blabbering. Storytelling as in what you know and how do you articulate. That will make you get the edge over your peers for sure. Okay. Just, I mean, does it mean that I was very good at it from beginning? In fact, I am pretty late. I'm still at this age. I'm still trying to get into that habit. Okay, because this is where I see that wherever I go, wherever we work, right, there are 5, 10, 20 people at the same level. Somebody has to still make a judgment that who is better among the entire gang, and that decision is made based on who articulates the best possible way. So that is where learn something, get this in your head, talk to yourself, say, okay, fine, if I have to tell this to somebody, this is how I can compile it. So, I mean, this is outside the syllabus of math. You guys are perfectly fine, you are much ahead of time, but once you get into that habit of explaining things, you'll find a difference actually. You'll see what I'm saying. Not now, maybe 2-3 years down the line, but you'll see a difference. Okay. Did I make anybody get tired of my speech, or it was making sense? Yeah. Tanvi, Shiv, do you guys agree to what I'm saying, Beta?
Yes, sir.
Tanvi, what do you think?
Yes, sir. I agree.
Yeah, math is a very point blank subject where you don't really have to do storytelling, but it's more of a way to articulate. That's what we're trying to get into. All right. So yeah, sorry, I stopped in between actually. You were compiling your story.
So we got a times r to the power of n minus 1 because we saw that each time that it went up, it's like right on my paper while I'm speaking. So it's each time that it went up, it is like it multiplied by the ratio, but it also it's like.
Just going to iteration. Go ahead.
It's like squaring each time compared to the regular one. Because if you try doing like 2a or something like that, just like the last one, it won't be this. It won't go the same way. So you have to multiply by the ratio and the ratio only, and then the ratio squares or multiplies by itself each time.
Right. And the biggest observation that you guys made was that my nth term is always one power less. The power to r is one less than the number of terms I'm talking about. So that is how this was your nth term. What was the second one? Arush, you want to give it a shot?
The second one we found out for geometry, for the sum of all the geometric sequence, like the first 10, I guess, first 10 sum of all those.
Mm-hmm.
And we found that by taking the sum and then we wrote all those numbers out, and then we took the sum and multiplied that by r and wrote all those numbers out,
Mm-hmm.
and then we subtracted them as well. We got some terms,
Mm-hmm.
and then we took those terms and turned them. That turned them.
This is the formula we got. So see now, now to whatever you said, right? Same thing here. Even if you forget this formula, I mean, in my wildest dream, I would not remember this formula. Trust me. I was able to write this formula not because I'm super intelligent. It was because I revised this before the class. Okay. If I had to memorize this, I would have done a horrible job. Okay. So that's why I can forget this formula, but what I would not forget is the story that you told me just now. Okay? Tanvi, Shiv, do you guys want to give me a quick summary of what we learned?
So first we just took a quick summary of the previous class, which was about the other sequence,
Arithmetic sequence. Yeah.
arithmetic sequence, and then after that we went and started the geometric sequence. And then you like asked people about what you thought, what you think it was. Then it was like multiplication, division compared to addition, subtraction. Then you showed us like the example. Then you showed us how you find dn and sn. And then we did a question on it, which is the 7. A is 7, R is 2, and N is 10.
Right.
And then we got SN is 7161 and D10. DN is 3584.
Right. So Tanvi, anything that you want to articulate? Do you want to come out of your comfort zone and tell a story?
We learned about, like, we revised arithmetic and geometric sequences today, and like Shiv said, we also learned about SN and DN, and we did like a lot of example problems.
Right. And so in summary, like, I mean, I literally wasted everybody's 1 hour to teach only 2 things. How do you find the nth term of a geometric series? And how do you find the sum of n terms of a geometric series? These are the only 2 things that we learned. Where we spent more time was just to wrap our head around how is that those formula derived, or how do we generalize the whole thing so that it gets registered here as a concept rather than a small bite in the memory of our brain. So that's where we put the effort, and that effort is worth it because you will see that it will be easy for you guys to recall it when you come across this. Now, we don't have much time. We have another 2-3 minutes. So I'm not going to do any more problem right now, but I want to give you guys another notation that you will see very often. This is called sigma. So it is very different from the sigma male that you guys talk about. Right, my younger daughter is in middle school, right? So she keeps talking about skibidi, sigma, and all those things. Okay, so this is very different from that. This is a very authentic mathematical concept. This sigma is used for denoting the sum. So if you are talking about, let's say, geometric series, okay, 2, 10, 50, whatever, n terms, or let's say if you have to find out first 5 terms, you will denote this as sum of n terms, okay, where it starts from a value of 0, this is the first term, and goes till k equal to n minus 1. Or you can say I can start from 1 and go till 1, whatever it be the case. So this just denotes a sum of terms. Whatever we did, this is just a representation of it, and it's called sigma. So next time when you hear sigma male, sigma from your friends, this is another flavor of sigma actually. That's what you can relate to. Yeah? Shiv, does it sound very familiar to you as well? I mean, you must be hearing it more often than other kids in higher grades. Yeah. I mean, trust me, when I heard this word sigma from my daughter, right? I mean, I was taken by surprise. Sigma is a different thing altogether. I mean, we used to break our head to find out what is sigma here. This sigma is like omnipresent. Everybody is sigma well. All right, let's move on. So, I have put some questions here that we wanted to practice, but since we have almost reached the time for the class, I will not try solving many of them. I will just show you guys. Let me read one problem and then we'll see if we know how to solve it or not. At least if we know the conceptual part of it, then that gives me the confidence that yes, we are good. There is a question which says a1 equal to 1 minus 1 by 3, ai, the ith term, is equal to ai minus 1 times minus 3. Find the sum of first 75 terms in the sequence. Sum of first 75 terms. Okay. So what do we have here? We have just a1. This is the first term that is given to us, and then says ai is ai minus 1, the term before that, times minus 3. It's asking us to find out the sum of first 75 terms. Don't try solving it. Tell me the story. How will you do it? What is that you know from the question, and what would go in your mind to be able to solve it? I'm just reading the question one more time. A1, which is my first term, is minus 1 by 3. And then I have been given a generic formula saying AI is equal to AI minus 1, not AI as an artificial intelligence, AI, ith term, is equal to I minus 1th term times minus 3. Find out the sum of first 75 terms. Now, any series, be it arithmetic series, be it geometric series, what we are concerned about? First term, common ratio, nth term. If it's a geometric series. If it's an arithmetic series, we are concerned about first term, common difference, and that n value. That's it. Now if you look at this one, is this an arithmetic series or geometric series?
Geometric.
Geometric series. I will rub this off. I don't need this to distract me. Now, from this, what is the value of A? What is my first term?
First term is negative 1 over 3.
Negative 1 over 3. Okay. What is my common ratio? Let me get it from the screen. Okay. Just save or Tanvi. What is the common ratio that you see from this problem?
What's the question? Is it sum or?
It's the
Sum of first 75 terms. Yeah. So Tanvi and Shiv. Do you guys want to tell me what is the common ratio here?
Negative 3.
Negative 3. Wonderful. Okay. And then n is already given to us, right? Sum of first 75 terms. Now, tell me if any of you will have any doubt with respect to how to do it. We only need first term, common ratio, and the number of terms. This is also given as 75. Now, if you remember the formula, wonderful. If you don't remember, that is even better. Okay? Sum of 75 terms. Or you can call it as sigma. K from 0 goes till k equal to 74. And here that will be nothing but A, which is minus 1 by 3 times 1 minus R. R is minus 3 to the power n divided by 1 minus R, which is minus 3. Do the magic. Yep. So, all the 4 problems that I have put, those were taken from Khan Academy only while I was just going through the concepts, and there is a unit test also. So, what I always suggest all of my kids is, all my kids as in kids who are in level 3 or pre-calculus, I don't give you guys assignment, right? I want you guys to, after the class, whenever you get time, spend half an hour, do the unit test on Khan Academy for the respective topic, and without going through what is there in Khan Academy, okay? If with the concept that you have picked up, if you are able to solve everything without any problem, you're good. If you want to practice more, find out EXL, find out online questions, sample questions that you can find out, try it, and as soon as you find something more complicated than you anticipated, guys will love me. Yep. With that being said, any questions? Shiv, hungry for dinner? Is it clear to everybody?
Yes, sir.
Okay, alright. So Tanvi, go ahead, enjoy your breakfast. Kids here in US, go and have your dinner, take some rest. Whenever you get time, do some unit test. And if you find some interesting problem, don't hesitate to share that with me. Alright? We'll do more with geometric series in the coming class, where we'll look at some word problems, some interesting relatable concepts. So this was just the basic or the foundation or the building block of these concepts, which we have just learned, and without putting any effort to memorize it, we have looked at the conceptual part of it. Rest all we'll deal with in the coming class. Yep. Alright. Okay then, take care.
Thank you, sir. Bye.
Bye bye. Bye bye.
Bye, sir.
Bye bye.